Welcome to my channel, viewers. See, here is some problem of competitive exam for 10+2 exam and others for JEE, IIT and main and advanced. Okay, so see, here is the first problem is q root of 5 root 2 plus 7 minus q root of 5 root 2 minus 7, and this number is rational, irrational, positive and unknown. So this type of problem was given in a different type of competitive exam some few years ago in India. Okay, and it is this type of problem is most essential for the competitive exam of Indian Statistical Institute exam. Okay, see here, and this, let us assume, and this is as a x, this is 5 root 2 plus 7 minus q root of minus 7. So cubing both sides. Then x cube is equal to, if you cube a minus b whole cube, so that is here 5 root 2 plus 7 a cube minus b cube. This is 5 root 2 plus 7 minus 3ab, and cube root 2 cube root of 5 root 2 plus 7 and cube root of 5 root 2 minus 7, and see within the bracket this minus in that place we have to put here as a x. So this is as a x cube, these two terms are cancelled, and this is here 14 minus 3, and this is here a plus b, a minus b. So 5 root 2 whole square and 49. So this is here x cube, 14, 3 and cube root of 50 minus 49. So see, x cube, this is here 1, okay, this is here 8 actually. So this is here 3x minus 14 equal to 0. And now we have to find the value of x by putting by choosing, that is called the trial and error method. So if we put here 1, then we get here 4 minus 14 is 4 minus 14 is minus 10. So that value does not satisfy. So if we put here 8, putting x equal to 2, then this is here 8 and 6 14, so satisfied. So this value is satisfied to this equation, therefore the solution, one value of x is here is 2. But other equations C need to solve that. See here x minus 2 and x minus 2, this is a 3 factor. So finding these equations, so doing here x square, so we get here x cube, so match with x cube. If we multiply this here, then we get here 2x square. So 2x square, but this is here absent, so we want to get here 2x square again more. So 2x square. So this is here minus 4x. Okay, this is here minus 4x, but we want to get here 3x. So we want to add with the 7x, then we get here 3x. So we get here 7x, we multiply by 7. If we multiply by 2 by 7, then we get here minus 14, and this is matched with that. Okay, so this is x minus 2 x square plus twice x plus 7 equal to 0. Therefore either x equal to 2 or x square plus twice x plus 7 equal to 0. When x square plus twice x plus 7 equal to 0, then we get here minus 2 plus minus root over b square minus 4ac 4ac by twice a. So 6x is equal to minus 2 plus minus 2 root over minus 6, and this is not possible. Okay, this is not possible, okay, as it is a complex, and confirmly we say that the value of this expression is real, so only we get this value as a real, and this real value is a rational number. See here, q root of this is positive plus positive value, that will be a positive, and also this is more than the 7, so that is actually root 50 minus root 49, so under root this value is positive here, so difference between the this is more value and this is less value, so their subtraction will be a positive value. Okay, we don't get a complex number here, so that's why we don't get this solution. So this is acceptable, and this is x equal to which is rational. Okay, see the next question. X square is equal to 4 to the power 2/3 and 4 to the power 1/3 plus 4. Now we want to show the x cube minus 6x is equal to what? Minus 6 minus 5 2 or 3 and 4 and or 3. Okay, see here. So x square is equal to 4 to the power 2/3, 4 to the power 1/3 plus 4. See, here is a x square and this is here 4. 4 is a rational, and this expression is irrational pattern. So that's why we rational term are subtracted to the left hand side, and right hand side is there. Okay, and this is here 1/3, 2/3, also cubing both side. Okay, x square minus 4 doing whole cube, 4 to the power 2/3, 4 to the power 1/3 whole cube. See, x to the power 6, 4 to the power 6, 4 4 16, 4 4 64 minus 3ab within the bracket x square minus 4. This is if we cubing this, then 4 to the power 2, cubing this 4 to the power 1, 3 into 4 to the power 2/3, 4 to the power 1/3, and under value of this is 4 to the power, within the bracket here is 4 to the power 2/3, 4 to the power 1/3. In place of that we can substitute x square minus 4. Okay, see, this is x to the power 6, 64, 12 minus 12 x to the power 4, and this is here 48 x square. Okay, 8 12, this is 8, no, this is 16 plus 4 is 20 plus 3 into 4 x square minus 4. I can see x to the power 6 minus 12 x to the power 4, 48 x square minus 64. This is 20, this is 12, and 48. Okay, this is here 48. Now x to the power 6 minus 12 x to the power 4 and 48, and this is 12, this is plus 36 x square, and now this is a 64 plus 20 minus 48. So this is here 84. 84 minus 48. 36. Okay. I want to get here x cube minus 6x. So x cube. So this is cube whole square minus 2x cube into 6x plus 6x whole square, and this is 36. So x cube minus 6x whole square equal to 36, implies that x cube minus 6x is equal to plus minus 6. Okay, and same problem is given to the some competitive exam in India some previous year ago. Okay, so this is a very important question, these two. Okay, and option A is satisfied, and for one is A. Okay, so now first question number, now next question is 4 here. Okay, now question number 3, 1 to cross checking later. Now here is the x1 and y1 are to the extreme coordinate extremities of the parabola. So that's why they have the equation through this and this. Okay, therefore then this is the equation of, actually this is the chord. Then the chord is, then the chord is which one of the equation. So the equation of the chord through x1 comma y1 and x2 comma y2 is y minus y1, y2 minus y1 by x2 minus 1 and x minus x1. See, when the curve is also passing through the 2 point, then we get here 1, and this is here x1 and y1 square, and also y2 square equal to 4ax1. Sorry, this is x2. If we define these two, then y2 square minus y1 square, and this is here 4a into x2 minus x1. So y2 minus y1 divided by this factor x2 minus x1, that is equal to 4a by y1 plus y2. And substitute to this equation in place of that is this. Okay, 4a by y1 plus y2, and this is x minus x1, implies that if you multiply this, y minus y1, y1 plus y2, and this is here 4ax minus 4ax1. Okay, now see again, if you multiply y, so y1 square plus y1 and y2, this is 4ax, 4ax1. Actually, see here 4ax1 is another plus 4ax1 and minus minus 4ax1. If you multiply by minus, then y, y1, y2, see y1 square minus y1, y2, 4ax plus 4ax1. Okay. We multiply this. If we added by y square plus y plus, so these and these three terms, y minus y1, y minus y2, and in place of that, this is a y1 square, this we can write as 4ax1. So this is y square minus 4ax and this is a 4H1. So these are satisfying which option? Option B. Okay, very interesting question. See carefully. Now proceed to the question number 5. We have given the condition for the function x of x plus y is equal to x of x into x of y. Find if we put 0, 0 actually, and this is then f of 0 is equal to, okay, therefore f of 0 is equal to 1. Now for it is given that the f dash 0 is 3 here, f dash 0 is equal to, and now we have to find f dash x. This is our limit h tends to 0, f of x plus h minus f of x by h. Limit h tends to 0, f of x, f of h minus f of x by h from that. Okay, so limit h tends to 0 by h. So now you have to put there f of f dash 0 here. So this is f dash 0. So that is f of 0. So limit h tends to 0, f of h minus 1 by h, and this f dash 0 is here 1. So this is there actually, this value here is 3. So 3 is equal to, this is 1. So limit h tends to 0. Now find the value of f dash 5. So again we write here f dash x, and this is here limit h tends to 0 by h, f dash 5. Okay, now f of 5, and this value actually here is 3, and given that the f of 5 here is 2, so this is 2 into 3 equal to 6, but absent, these values absent here, so option number D here. Okay. For question number 6, x to the power 6 is equal to root 2 over 2. Okay, let and x to the power 6 they are, let us assume as y. So x to the power y, and this is root 2 and whole to the power root 2, and this is root 2 whole to the power root 2, and this is just 6 by 6, see, and root 2. For 6, 3, and this is 8, and this is 6. So okay, and this is root 2 cube. Root 2 cube means root 8 whole to the root 8 by 6. Okay, therefore x to the y whole to the 6 is equal to root 8 whole to the root 8. So x to the power 6 y is equal to root 8 whole to the root 8. So x to the power 6 whole to the power y, root 8 whole to the root 8, and this is also y to the power y. Okay, so we can write here y is equal to root 8. Now y means, and this is x to the power 6 and root 8. So x is equal to, this is 2 to the power 3 whole to the power half and whole to the power 1 by 6. Okay, this is 2 to the power 3 by 12. This is 2 to the power 1 by 4. This is 4 to the power 2. Okay, see the solution here. The next problem. Is question number 7. Question is that find the number of diagonals of an hexagon. For if we have a given the inside of polygon, so this is, let us assume this is the inside of polygon. Okay, if we join these diagonals. So this is n to number of lines we have to get here. But these n number of sides are not a diagonal. So subtracted from that. So this is the number of diagonal. And same as for hexagon. One, two, three, four, five, six. If we join this, okay, see, here is a hexagon. So number of lines, straight line will be 6, C2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, okay. This is the number of line. Now including here is involved the 6 side. So 6 sides are subtracted, then remaining all are the diagonal. Same as for that, this is an inner one. So n 9c2 minus 9 is your answer. So factorial 9, and this is a factorial 2, factorial 7 minus 9, and this is 9 into 8 by factorial 7 are cancelled. This is 2 minus 9. So this is 36 minus 9 is equal to 27. This is the number of diagonals for question number 7. Okay. And for 8, see, actually E, exponential. E series here is e to the power x is 1 plus x by factorial 1, x squared by factorial 2, x cubed by factorial 3, like that, okay. If we put here 1, then we get here 1 plus 1 by factorial 1, 1 by factorial 2, 1 by factorial 3, like that. Okay, so if we get this, then we replace by E. And now we have to find the general term of that. So this is here Tn. 1 cube by factorial n, 2 cube by factorial, so n cube by factorial n. So need to cancel n to the numerator term. So if we cancel n, then we get here n square, then here is a n minus 1. After that, we want to cancel n on the upper, so that is n minus 1 by plus 1 by n minus 1. So n square minus 1 by factorial n minus 1 plus 1 by doing n minus 1. So then n plus 1 by n minus 2 here. So n minus 1. Okay, so again here is n minus 2. So I want to get here n minus 2 and plus 1. So that is why I bring plus 3. So n minus 2 and this is here 1 by n minus 1. So see this by this, so here we get here n minus 3. So this is 3 by factorial n minus 2 and 1 by n minus 1. Now putting n equal to 1, 2, 3 and dot dot dot, okay. So this is at t1. So we get here 1 by factorial negative, and 1 by factorial negative here is a 0. Actually this is infinity, so 1 by this is 0, okay. So same as 1 by factorial negative. So this is infinity, big number, so 1 by that is equal to 0. So same as 1 by factorial 0, this is only 1. So this is 2. If we 2, then we get again 0. If we 2, then factorial 0. Factorial 0 means 1. So we can write here 3. And if we put here 2, then 2 minus 1 factorial 1. We can write here like that 1 by factorial 1, not 1. This is 3. If we put here 3, then we get here factorial 0. So this is here 1. So same as factorial 1. So 3 by doing factorial 1. Let's write here factorial 1. So this is here factorial 2. Again we write here factorial 4. So we get here 1 by factorial 1. So 3 by factorial 2. And this is 1 by factorial 3. So again factorial 5. Sorry, this is 35. So 1 by factorial 2. 1 by 3 by factorial 3. And 1 by factorial 4. So like that, okay. So if we doing sum this, then we get here the series is here 1 plus 1 by factorial 1, 1 by factorial 2, okay. Same as taken power 3. So 1 plus 1 by factorial 1, 1 by factorial 2, okay. And same as for the series is 1 plus 1 by factorial 1, 1 by factorial 3, dot dot dot, okay. See, from this here is a E, a 3E, and this is E. So 5E. So option here is A. Okay, and for 7 is A also. So see, I need to solve this question with a 10 second. This is a 9. Now see, y is equal to tan inverse 4x by 1 plus 5x. So we can write as 5x minus x by 1 plus 5x into x. And tan inverse, for that if we divide it by 3, numerator, then we get here 2/3 plus x by 1 minus 2/3 into x. So therefore we can write the formula here is tan inverse 5x minus tan inverse x. So tan inverse 2/3 minus tan inverse x. So these two terms are cancelled. So if we differentiate this dy dx, so we get here 1 by 25 x square, and differentiation of 5x here is 5. So this is your answer, option A. So for 10 number question, see, for a properties of triangle is given that a plus b plus c and a plus b minus c is equal to thrice ab. If we multiply these two, then we get here a plus b whole square minus c square and thrice ab. Okay. So now a square plus b square minus c square and subtracted twice ab to the right hand side, then we get here only ab here. So divided by a square plus b square minus c square by twice ab. So this is a half, and this is the formula of cos c. So cos c is equal to half, and this is cos 60. So c equal to 60 degree. Okay. So this is option is A. Now only 3 we have left here. So C. For 3. So this is here sin square 4 alpha by A cos square 4 alpha by B equal to 1 by A plus B. Now right here, this is here sin square whole square, and this is here by A. This is here cos square whole square by B and 1 by A plus B. Let sin square alpha is equal to x. So this is an x square by A and 1 minus x whole square by B, 1 by A plus B. See, dx square A into 1 minus 5x plus x square. And this is your AB. Okay. So A plus B into bx square, A into A plus B, okay, twice A into A plus B, x, and A plus B into x square is equal to AB. So now see A plus B into B x square, A square AB, twice A into A plus B into x, and A plus B into x square equal to AB. AB are cancelled. Okay. See, okay, I know can be missing. Okay. From these two, we take a common here, x square A plus B, and then we have left here B plus A. So minus twice A and A plus B into x plus A square equal to 0. So x into A plus B whole square twice x into A plus B into A plus A square equal to 0. So x into A plus B minus a whole square equal to 0. Therefore, x into a plus b equal to a. So x is equal to a by a plus b. X means this is a sin square alpha. Therefore, cos square alpha is equal to 1 minus sin square alpha. This is a 1 minus sin square means a by a plus b. This is a b by a plus b. So on the right hand side, on the given expression is that. So this is a sin square whole to the power 4 by a cube, cos square whole to the power 4 by b cube. See, sin square alpha, this is a to the power 4 by a plus b whole to the power 4. Okay, for that. And remaining here 1 by a cube, 1 by a cube. Same as cos square alpha, this is here b to the power 4 by a plus b whole to the power 4 into 1 by b cube. So see, that is the LCM of a plus b whole to the power 4. These are cancelled, a and this is b. So we get here a plus b whole to the power 3. So option here is 1 by a plus b whole to the power 3. Okay.